Hey, I'm Manuel from Steadybit, and I want to give you a small demo of the Steadybit product and the latest features we have been working on. At Steadybit, we strongly believe that chaos engineering has to be shift-lefted from the SREs or ops guys, so the people who are taking care of the stability of your applications, to the developers who actually build the applications, because it makes much more sense if they care about resilience as well. And this is why we are working on latest features which go actually beyond chaos engineering in order to make it easier to shift left chaos engineering to the developers. Because doing game days and thinking about experiments is pretty nice, but also very time intensive and hard for developers who usually are not thinking about these kind of questions. And in order to show you what this actually means in the Steadybit product, I will basically improve the resilience of a small online shop, which you can see over here. The small online shop consists of 4 microservices, so 1 microservice for each product category like hot deals, fashion and toys, and 1 microservice orchestrating everything together and delivering that online shop to the end user. This online shop is running in Kubernetes in an AWS environment, and it is basically developed using Java Spring Boot, as well as some React front-end stuff. So for this online shop, I have already installed the Steadybit agent, who is now constantly looking at the shop and discovering the components running over there and sending metadata about this to the Steadybit platform. And this is actually something I can see on the Steadybit platform on the dashboard. So you can see that there are 3 agents operating, and the 3 agents have discovered 3 hosts where the online shop is running on, as well as 4 Java applications and some Kubernetes deployments and Docker containers. And I can now look at the JVM applications, and you can see that these are exactly the 4 JVM applications I was just telling you exists for the online shop. All are developed using Java and Spring Boot, and they are running in 2 instances, so 2 pods per deployment. And this was automatically discovered by our agent. Well, seeing this now in a single table is nice actually, but it doesn't give you any visual representation of how your system looks like. And in order to foster a shared understanding of what your system looks like and give you some transparency about it, we have developed the landscape map. And here you can see again the components of the online shop in the Steadybit demo namespace. And you can also see the connections from this online shop and how the dependencies are working out. So you can see that there is a gateway ingress which is connected to the gateway. And as soon as a request is coming in, it actually asks hot deals, fashion and toys for its products. And this happens via HTTP. Steadybit is able to actually discover all these connections using eBPF in order to display them over here at the landscape. And this is something which is a great start for instance, a chaos engineering game day, and now thinking about what experiments we would like to run and execute, and afterwards executing them using the experiments tab over there. But as said, this is still some things which require you to invest time, and developers are usually very focused on building features and getting them out there as quickly as possible, and they don't have much time in order to think about how resilient the application really is as of now and how to improve it, because in the end it may pop up in some backlogs which product owners prioritize and don't give the developers time to actually make it more stable and more resilient or more robust. And that's why we believe in that there are people who have knowledge in resilience and chaos engineering, and they are actually enabling and helping the developers to do that and to think about these cases. And in order to do that, we have built something which is called resilience policies, which I want to show you right now. And these are the mechanism to actually shift left it. So you can already see that there are some pre-configured policies applied on hot deals and toys, but I will simply show you how to set up a new one. You can either do it using the Steadybit's UI or the CLI, and I will use the CLI-based approach, which enables you basically to do it automatically, maybe in a CI/CD pipeline later on. Therefore, I will jump over to the CLI, and I'm now in the gateway component source code level. So this is the source code of the gateway, and I'm able to actually describe the service by using Steadybit service init. This way I'm able to describe what are my expectations for this gateway component, which resilience patterns or resilience things should be addressed by this component. I'm initializing the service description. First of all, I have to give it a name. In my case, gateway component is fine. And then I have to choose which resilience policies should be applied to that gateway component. And there are already some predefined policies coming from Steadybit, which are based on best practices. Like, for instance, a policy going around recovery of a single pod or redundancy of pods or hosts, and even more like rolling update and loose coupling of the deployments. These policies usually consist of experiments, which are chaos engineering experiments indicated over here, as well as some weak spots. And weak spots are things where we basically check the current configuration in the deployed environment and can automatically tell you whether there's something missing in order to make it really resilient. And these are simple to use and easy to be fulfilled from the developer perspective, and also pretty easy to be applied from the SRE or ops or basically chaos engineering experts level. You can use these predefined policies or even create your own and extend it step by step by just publishing it in a GitHub repository. But let's focus on the existing ones for now. So I want to check for gateway whether the redundancy on pod level works out in the end. Therefore, I'm jumping back to the CLI, choose the challenges for the pod redundancy, apply them, and hit enter. Next up, I have to apply or provide a mapping in the Kubernetes cluster. So this gateway component, where is it living at, and where should I apply or Steadybit apply the policies to? In our case, it's living in the demo prod Kubernetes cluster in a namespace called Steadybit demo, and the Kubernetes deployment is the gateway component deployment. Now, Steadybit is asking me to provide a load-balanced HTTP endpoint, because in the end, we want to make sure that the redundancy is working, and this way have to provide an HTTP endpoint which is used in order to be load balanced between the existing pods. In my case, that's a public URL available under this address, but it can also be an internal one, which is then checked by the agent running in your environment. Now I have to define some role-based access control mechanisms, which are teams and environments, because in the end you want to make sure that your team is only able to provide or do some attacks or experiments which are in the scope of the team. So you want to maybe prevent that every team is able to shut down every host, but maybe only those connecting to your environment where the team is working on, or even not that at all. In my case, I'm using the online shop team, and I'm going for the online shop prod environment. And now Steadybit has actually created a Steadybit service definition, which contains the resilience policies I want to fulfill in the end and the mapping where the policy has to be applied. The cool thing about it is this file is just living on your computer, and you can simply upload it, for instance, or commit it and push it to your Git and use it, for instance, in your CI/CD pipeline to automatically apply these resilience policies and check them. In order to apply it, I just have to write Steadybit service apply, and I can show you what happened then. You can obviously see over here in the landscape that the gateway component is currently without any resilience policies, and as soon as I'm applying the policy, you can immediately see that there is already some progress made in the resilience policies. So you can see that 67% were already succeeded in checking the resilience policy. And looking into it, there are exactly the two weak spots which I have just explained to you, especially the readiness probe weak spot. So the Steadybit agent was able to identify that the readiness probe has been configured for the gateway component, and there is no need to do anything like an experiment for that, because we know it's already there. We can, for instance, check whether it's working by using the experiment which was created as well. So it would basically stop a single container and check the HTTP endpoint whether it has at least a success rate of 95%. And this way we can actually make proof of our configurations that it is working in the end. And these are things which are definitely going beyond chaos engineering and makes it easier for developers to actually start with the topic of resilience engineering. But there is even more. I mean, right now this is just an experiment, and in the end the developer still needs to figure out okay, how can I improve this now? And that's something where we are currently working on as well to support the developers in this journey. Therefore, I will use another resilience policies, which is all about HTTP clients, and add this policy using the UI. You can see that Steadybit has actually created 3 additional experiments, and all these 3 experiments are related to what happens to the gateway products endpoint when Hot Deals is answering with, for instance, 500 instead of delivering HTTP status 200 connected with all the products. And the same applies for the fashion and toys bestseller experiments. So I have now a simple experiment which I can have a look at or just execute it. We will first have a look at it. And you can see now that Steadybit has automatically created an experiment where it will inject HTTP request errors for the product endpoint so that the responses will be 500s. And while doing that, it will constantly check the products endpoint whether it delivers you the products or whether it is failing at all. And to see that in action, I will run the experiment and also show you the online shop on the right-hand side while doing that, so that we can actually see how the online shop behaves. Run the experiment. Now the Steadybit platform is connecting to the agents and automatically identifies which agents are the right ones and executing the experiment. And you can see at the top the status of the experiment, as well as some information about your cluster going on below of that. And you already noticed probably that the online shop had some hiccups on the front end side. You can also see on the widget over here that there are some HTTP response resolving as a 500 in total, and some are in a HTTP status 200. And this is exactly natural because we are introducing the request errors at some time, so that the requests are not fulfilling at all, and the online shop is not working anymore in a sufficient state. So this is really, really bad. I mean, now we have identified that it's not working and we have to fix it somehow. And that's something where chaos engineering usually stops. Now you have to identify on your own what's going on, what's not working, and especially how can I improve it in the end. And we thought that this is also some things where we can provide the developers with some guidance. And we have made first movements into that direction, and we call it autofixes. So going back to the gateway component, we can see that the experiment has actually failed, but Steadybit suggests us to add HTTP retries. And the nice thing about that is that we can automatically add these HTTP retries to the JVM application without any code change at all. We just use bytecode instrumentation to actually apply it. And I mean, that's very great for an application which is right now in a bleeding state and it's not working as expected, and you want to, as fast as possible, get rid of the resilience issue. You can just use the default ones, which Steadybit automatically suggests to you, or you can even add more configuration to it. Now clicking Save, and as said, the patch is already applied to the application. And because we have an experiment for it, we can even try it out, whether the patch is working or not, and whether the configuration is good or whether we want to adjust it. So again, I can simply run the experiment. And now the patch is applied. So let's see how the application works in the same turbulent condition. You can see that we are injecting the HTTP request errors, but over here are much less, or in total right now none of any problems. The online shop is still working as expected, and basically the end user is able to buy products and this way generating some revenue for the company. And this is a really great proof that going beyond chaos engineering is actually very important in order to make the resilience working in the end. That was everything I wanted to show you for today, and I'm pretty sure there will be more updates coming. If you have any questions or problems in getting started, feel free to reach out. And otherwise, just go on steadybit.com and click your own tenant by using our sign-up form and trying out Steadybit. Thank you, take care.